Nicolette, what's up?
Oh, nothing. Just looking up scuba classes on bluewaterdivers.com, located in Rochelle Park, New Jersey. How about you?
Nothing much. I wanted to find out if you wanted to watch a magic trick.
I guess.
Alright. Watch the balloon.
The balloon, it's getting smaller, but how?
Well, let me tell you about it.
Boyle's law states that at a constant temperature, pressure is inversely proportional to volume. The equation can either be written as P equals K over V or PV equals K. P stands for pressure, K stands for temperature in degrees Kelvin, and V stands for volume. This graph shows that as pressure increases, volume decreases, and vice versa. As pressure on the balloon increases, the volume inside of the balloon decreases.
Well, that's enough magic for today.
But Nicolette, don't you want to see the second magic trick?
I am too educated for your magic tricks, but I will entertain this one one more time.
Thank you. So just watch the balloon again.
Yes, the balloon gets larger, but now I know it's all due to gas laws.
This time, as pressure on the balloon decreases, the volume increases.
Nicolette, are you sure you don't want to see the third magic trick?
Hell no, I'm done with you. I'm done with your magic and your pseudoscience.
Patricia,
What's up, Haley?
do you want to watch a magic trick?
Sure.
Okay,
Yes.
perfect. Come sit.
Oh my gosh, it's so cool. I have to call Nicolette and tell her to come see this.
I don't think
Oh,
that's a
hold
good
on,
idea.
hold on. I got this. Hold on.
Well, here's how I did it.
To the left is a cup of water, and to the right, a carbonated drink. The pH indicator methyl red is added to both. At a low pH, methyl red indicator turns red, and at a high pH, it turns yellow. Water turned yellow, and the carbonated drink turned red.
The pressures decrease within the tube, therefore decreasing the pressure of the CO2 in the carbonated drink. After mixing, the color goes from red to yellow, indicating the carbonated drink has become less acidic. This is because under lower pressures, gases are less soluble in the solution. The CO2 has diffused out of the solution. The gas laws explain how this occurs.
Dalton's law states that the sum of each gas's partial pressure is the total pressure of the mixed gas. This law is illustrated here. Gas A alone has a pressure of 300 millimeters of mercury. The pressure of gas B alone is 400 millimeters of mercury. Together, gas A's partial pressure of 300 and gas B's partial pressure of 400 are added together to solve for the total pressure of the combined gas, 700 millimeters of mercury. Henry's law states that the solubility of a gas in solution increases as its partial pressure increases. This picture shows the difference in solubility of the red gas molecules when under higher pressure. At increased pressures, they become more soluble in the black molecules, demonstrating Henry's law.
Here are some anatomical explanations. In this experiment with the balloon and syringe, think of the balloon as a lung and the black stopper as a diaphragm. When the diaphragm descends, the pressure on the lungs is decreased. This results in increased volume inside of the lungs, causing the lungs to expand. Dalton and Henry's law can be applied when learning how to scuba dive. A major component of the air we breathe is nitrogen. Therefore, nitrogen gas is constantly in our bodies. As a scuba diver descends into higher pressure, that pressure is applied on a nitrogen gas in the body. Because the pressure on a nitrogen gas is increased, its solubility is also increased. Because of this, the nitrogen dissolves into the tissues of our bodies. When a diver ascends into lower pressures, the nitrogen becomes less soluble and exits the tissues. Nitrogen leaving the tissues too rapidly can result in decompression sickness. So a major fact that divers should remember is to rise slowly so that the nitrogen does not exit the tissues too fast and cause this problem.